She's calling me. Guess I'll slide away. I've got to feel her touch most every day. She's warm and she's wild, calls me her child. I warm to her touch. She's my mother ocean.
But next up is Dr. Nikolai Maximenko from UH Manoa, and he's an expert on ocean circulation. I did want to mention real quickly that there are bathrooms as well if you need, and they're open and they're directly across the way, this way, men's and women's.
Good morning. I would like to say in the beginning of my presentation, there is something very special about science of marine debris. Compared to other disciplines where you can measure temperature, radiation, it is really difficult to measure marine debris. Our knowledge does not come from really reliable and well-developed observing system. It cannot be measured just by some in situ observation or just by going one time at some place. So these fragmentary observations, they give us hints, and from those hints we...
Bring the microphone up a little bit. It's a little quiet back.
Okay. And from those hints we derive our knowledge, and we use these hints to develop our models, trying to provide some broad view, large-scale view from tiny fragments. And because of that, individual observations, individual reports and initiatives, they're very important. And I want to start with thanking very much Dr. Carl Berg for organizing and maintaining this series of meetings, and also him and his group and his organization for actively monitoring coastline on Kauai. This is my first slide. It's actually not for today. This is the slide from the previous meeting that was held in December 2011. And I want just to remind what we knew at that time, less than 1 year after tsunami. And this is the first the title of my today's presentation with some small changes in partnerships and titles. So as at that time, and still I think we are terrified with memories of this huge wave that just destroyed and washed away cities and villages. And my friend Yutaka Michida from Japan, he shared with me these photographs on this is his research institution, a three-story building, and half of that building was just covered with water at the peak of the tsunami wave. And in the town, nearby town, after tsunami retreated, you could find not just boat like we are finding on Hawaiian coastlines, but pretty sizable ships sitting on roofs of your houses. As a result of tsunami, tragically, lives of approximately 16,000 people were taken, And according to estimates, to best estimates of Japanese government, tsunami created 20 million tons of debris, out of which 5 million tons was washed back into the ocean. And out of this amount, approximately 1.5 million tons was floating marine debris that then was floating away from Japan. When asked by journalists, Curtis Ebersmeyer from Seattle, Washington, when he was asked about composition of the debris field, he said, just imagine you take this city, you put it into a huge grinder, and this is what you get. Everything was mixed together, just as you can see on these images. And a few days after tsunami, when thick mats of debris were floating away from Japan, many photographs were available from different sources, including US Navy helping Japanese people at that time. 1 month later, after that, tsunami disappeared, literally. We did not know anything about it. It was not seen on satellite images. It was not seen on reports. It was not reported by ships. It was not found on coastlines, of course, except for Japanese coastline. And at that time, when there was very active exchange of opinions, what should we do? What should we expect? Actually, dominant opinion was like nature is smart enough to take care about it. Marine debris is not something new. We have a lot of it all the time. Most of debris from tsunami in Japan was obviously wood from broken houses. Wood cannot float in water for too long time. Some months later, it will sink down or it will be eaten. And so there were not really much worries on our side in the US, although there were consultations. When trying to organize the effort to confirm the existence, still the existence of the debris, we were running around many different people, companies, agencies, and talking to them personally. That was, again, very important to speak personally. And first report that we received, it came just from a couple sailing from Yokohama to Alaska, and they sent just short, brief message, text message. You can see the area where they ran into a thick, dense concentration of all kind of debris. They saw large pieces of styrofoam, they saw refrigerators, and they saw a lot of lumber. They could tell it was from broken houses. Next opportunity came when a Russian sail training ship, Pallada, visited Honolulu before going to Yokohama. And we met with the captain, and we were lucky to convince the captain that this may be the big issue. This may be even issue of safety for the ship. Also, we were lucky because on this ship there were 200 cadets, which means 200 pairs of young and curious eyes. So they were watching the ocean all around the clock. After reaching Yokohama, this is what they told us. Soon after passing by Midway, they started seeing unusual objects. And at this location, they picked small fishing boat, and it's very difficult to quantify, but from their subjective feeling, the highest concentration of debris was here. And they could see it almost all the way until they reached Japan. But just before coming to Japan, they ran into a storm and observations became difficult. What is superposed here is our very early model for motion of debris from tsunami, these purple particles, and you can see it was really difficult to prove, to validate the model, but it was consistent. And what was alarming, from this report we knew that debris is approaching Midway, which is a very important area. It's, in some sense, it's most protected, at least by law, island in the world. So we were trying to organize kind of monitoring at sea, which was not available. And we were able to, well, we were lucky to meet two brave people who volunteered to sail in December. To sail in December northwest of Midway on a small sailing boat. And we raised funding, and we provided instrumentation, and we basically did not sleep for a couple of weeks, or slept in turn, because the only way how we could protect them from storms is by providing real-time and good quality weather forecast. And even in that case it was difficult, because amount of gas was very limited. They could only use, could only use sail, and it appeared to be not very good way to avoid storms. So we shrinked the original plan of the expedition to keep risk under control. They could not go too far north, but as far as they were able to reach, they collected samples of debris that they saw, and they deployed satellite-tracked drifting buoys, and also 400 of these wooden blocks. Each block had its number, they recorded where it was deployed, so that later we could track these trajectories. Conclusion was that as far as they could reach, they did not see tsunami debris. All debris that they saw, it was old plastic. By this allowed us, by combining model and satellite observations, to understand the situation, what's going on. And we realized that on that year we were lucky. What happened is there was a current, there was a kind of jet and associated front that was literally protecting Midway from tsunami spreading from debris spreading from Japan. So major currents were like this towards Midway from southeast, and this front was kind of redirecting debris from Japan towards northeast. Soon after that, Japanese cabinet of Prime Minister made public reports from Japanese fishing and research vessels. And then reports started building up on US side. First, buoys, oyster buoys. They started coming in increasing numbers. They were not a solid proof, and they were questioned by many people and agencies, because in principle they were seen in Hawaii and other states before. These buoys are used on oyster farms in Japan and around Asia, but the indicator was increasing number. Then ships identifiable debris. They really indicated that wave of debris is approaching US West Coast. And this is because of that front, that debris did not reach Hawaii on its way east. It first went to West Coast of US and Canada, and then recirculated back to Hawaii, as I will show later on computer movie. Then variety of objects, identifiable objects, started coming on West Coast. Football, motorcycles, do not float, but this container that was enclosing this motorcycle, it was walls were filled with styrofoam, so it was floating. It is difficult to really pull together these hundreds and hundreds of observations in some single concept. So the easiest way to do it in this limited time is by showing a computer scenario of what actually happened. I cannot control this movie, so I will just follow a couple of cycles, and then I will show just some snapshots. So you can see how it started from Japan, how it reached West Coast, how it recirculated to Hawaii, and then how it continues to change. Colors on this movie indicate different windages. What is windage? Forces acting on every object floating on ocean surface include wind force and ocean currents. Depending how these forces, depending how much, what part of the object is under the water and above the water, the object is more affected either by wind or by currents. So this is what is called windage. High windage, red on this movie, is something sticking high in water, like styrofoam, buoy. Low windage, purple and blue on this movie, is something sitting deep in water, like fishing nets. So a few stages of evolution, of motion of tsunami debris field. In approximately 1 year after tsunami, front edge, red, high windage debris reached west coast, and most of debris, we believe, was blown by wind on coastline. We still do not know how much was buried on coastline of Alaska. This is really empty area, hard to reach. What is left in water recirculated south and west, and in summer and fall of 2012 started coming on Hawaiian beaches. In Hawaii, again, first objects that were suspected to be from tsunami in Japan were oyster buoys, and first report came from Hilo. But then Camilo Beach, then reports from the ocean close to Oahu, and then from Kure Atoll. First object that was officially traced back and confirmed to be from Japan was this blue plastic bin, and it came in September 2012. And since then, we had everything. It is difficult to generalize and describe, but I will try to mention just some kinds of objects. Some objects were unique and even mysterious, such as this yellow buoy. It came on Big Island, and we still don't know what it is. Most likely it's a mooring buoy for big tankers that could be used in any big port, like Sendai port in Japan. This 40-50 foot dock, it was reported north of Molokai, again in September. It was visited by local fishermen 2 times, 2 days in a row, but later US Coast Guard could not find it. So it's still floating somewhere. This dock is the last unfound twin dock, same as was reported before from Seattle area, from Washington and Oregon. electrical bulbs, 500 watt large electrical bulbs. At that time, it was nearly impossible to say, are they from ships, overturned ships drifting from Japan after tsunami? And if yes, then we would have to expect ships coming next. There were big questions. It was really impossible to prove they are from tsunami. But now I think we have another argument, in addition to arguments that Dr. Carl Berg mentioned. Remember, he said the way how we can speculate about some particular object to be from tsunami are: it is rare in Hawaii, it can be traceable back. Another criteria now is that now we do not receive these bulbs anymore, just like we do not receive oyster buoys anymore. So this again confirms that was one-time source, and most likely it was tsunami. There was a wave of refrigerators, small refrigerators. And most recent that we are busy now with is wood. We are receiving dozens and dozens of reports, and many of them come from Kauai. Working with experts in lumber, biologists, and now we have pending DNA analysis. We are pretty confident that these species, they come from Japan, and they are mainly from broken houses. So, for example, this piece, what experts can say, this wood is Japanese cedar sugi. Also, the way how it's shaped, this is typical Japanese construction technology. We don't do this in America. How important this wood? Again, let me remind you that in the beginning, most of mats of debris, they were yellow and reddish color. That was because it was mainly lumber. It is now overgrown. It is heavy. It is soaked of water. It is difficult to see from boats. Yet boats report this debris. Last summer, about 50 sailing boats participated in Transpac race from Los Angeles to Honolulu. There were at least 19 reports of boat collisions with something in water. In case when people were able to see, they were racing, they were busy. When they were able to see what they actually hit, they were reporting electrical poles, telephone poles, lumber, logs, trees. So from combining these reports from coastline and from sea, and combining them with our model, the estimate that we have at hand is that still in the ocean we have somewhere between 100,000 and 1 million pieces of wood floating. It will not be floating for forever, because you can see how badly it is eaten by shipworms. So this is probably the way how it's going to decay. What impact will it have before it's consumed by shipworms? We do not know. There may be issue of alien species, invasive species, but we don't know that yet. And again, let me finish with the same request to you. Your reports are very important. Be curious, be cautious, but be also curious. You see something strange, you see something unusual, please take a photograph, reach us, give us this information. In many cases, people, when they send photograph, they hear back, they say, wow, we had no idea what it is. So I'm going to put my cards somewhere on the desk. Please pick up one or contact Carl Berg and ask to link with us. And if I have a minute, I just wanted to elaborate a little bit on connection between marine debris and radiation. As Henrietta mentioned, they were kind of generated at different times. They did not go in real contact, but there are, of course, radiation is a very hot topic. Everybody are more concerned about radiation. And this, excitement is sometimes heated by not so reliable publications, scientific publications, and Henrietta showed this model by Chinese researchers. And when they simulated what they call radiation, radionuclides, but in fact, when I see this movie, I see their simulation, they in fact simulated marine debris, and the difference is marine debris floats at the surface, and ocean surface currents are organized in such a way that they converge in the area between Hawaii and California. This area is now well known. There is a name, garbage patch. This is where fishing nets, microplastic, it collects and stays for years and years. So this is because surface currents converge, water sinks down, but debris cannot sink. It stays on the surface, and with this mechanism, its concentration can be increased. Radioactivity is completely different substance. It's dissolved in water. It does not float. So it follows water all the way down. And because of that, it also mixes, not like marine debris two-dimensionally, horizontally, but also three-dimensionally. And if you imagine the volume of the North Pacific, it's a huge volume. Even such major accident as Fukushima crisis, when mixing with these numbers of liquid, it really goes to really low values. What is when you are asking about should we be concerned and how well do we know, how well do we monitor radionuclides? It is a really difficult task. I was helping Henrietta to get some samples from our volunteers who were doing marine debris observations, and you need at least 20 liters of water. For small boat, it's already difficult. Then shipping 20-liter container of just seawater from Alaska to Hawaii, it appears to be not easy. You need to explain what are you guys doing? And then after that, they're using their what's the name? Chamber, and you need to actually to leave it overnight to count, just to process just one sample. So samples are really sparse. Every time when we were trying to use some existing models, which are different from marine debris models. So in radioactivity, I'm not an expert. So we were using somebody else's models, and we were finding people who were sailing across the pattern like this one and trying to catch maximum values. Maximum values are still so tiny that Geiger counter would not sense them at all. You need really expensive equipment for that. But still my concern is that with our observations, we are not resolving this pattern. We are not sure whether we are measuring in the maximum. So I think as an oceanographer, I have somewhat different interest in radiation, because radioactive traces that like X-ray are able to help us understand three-dimensional circulation of the ocean, which will help to understand climate change and climate dynamics. But there is still a lot of things to do in this direction, I think. Thank you very much.
So any questions for Dr. Maximenko?
What can we expect? What products could be coming to Kauai on the coastline, and when? Is there any? What's the prospect for 2015?
Let me just use this map just to explain what's going on. Now debris is not just mixed over a large area, not just scattered around large area, it's also sorted by winds and currents. So now we know that different kinds of debris, they're taking different paths. For example, whatever is avoided being washed on US West Coast, it's actually now in tropics and drifting along the equator towards Marshall Islands, towards Palau Islands, towards Philippines, this line. And this is not a coincidence that this is, maybe you remember this recent story by San Salvadoran, a guy who spent at sea for questionably 13 months. Our model says that his story is credible. And what is interesting, because our model indicates that there is convergence of surface currents that leads everything floating, well, not currents, convergence of surface winds. So everything that is high windage is collected by winds. And it's led along pretty narrow line. What is important, whenever wind converges, air upwells and creates rain. So he's saying that he had rainwater frequently. It's also credible. And one more thing is he did not see any ships for 13 months. That's why we do not have reports from that area. So our model can only say that if this debris exists, then it should be there. Whether it exists and what is the amount, we do not know. On the other end of the spectrum is heavy, low-sitting debris, such as wood, such as fishing nets. And this is bluish part. This debris is going to stay there. And seasonally, every winter, it's going to wash on Hawaiian coastline and west coast, and every year it will get more and more broken, weathered, yes. If you want to know when it will come, what and when will come on Kauai coastline in 2015, there are in fact two factors. One is what is out there next to the island in the ocean, and second is the wind. You noticed in Carl's presentation this Thursday, there were 2 boats reported. There were also reports from other islands of increased amount of debris. What happens is wind is important to bring something in water on shore. Without wind, floating objects, they just follow water and they move just around the island. And they may be out there in water, but we will not see them. So wind and timing.
This is very interesting, the lower picture. When the red, lighter floating stuff is passing Palau and Marshall Islands, is it then going back up to Japan?
from what I see on this movie, it's most likely going to end on Philippines. But now we are trying to reach Marshall Islands, Palau, Philippines. We do not have any partners there. We're trying to reach people who would be able to tell us. It's again, it's amazing. You cannot talk to government of Marshall Islands. You need to reach somebody, one curious local. One example is our volunteer. During his circumnavigation, he stopped on Easter Island, which is South Pacific, and he, according to our model, there must be another garbage patch right next to that island. And he did walk around and spoke with locals, and he found one guy who just opened eyes. There is same problem of marine debris on Easter Island as we have in Hawaii.
Garbage patch prior to the tsunami, where was it located in the Pacific, and did it mix with tsunami debris?
It was same.
Could you repeat the question?
Oh yes. The question is where garbage patch was located before tsunami and where it will be later. Garbage patch is permanent feature. Supposedly it contains plastic released in the North Pacific over recent 20, 30, 40 years. So it's in some sense it's much bigger feature than this tsunami, one-time experiment, nature experiment such as tsunami. At the same time, if we compare amount of debris in the garbage patch and in the source in Japan, I mentioned 1.5 million tons. Floating debris generated by tsunami, including wood, not only plastic. Without tsunami, what we usually have globally is approximately 10 million tons of plastic added to the ocean annually, which gives me number approximately 2 million tons of plastic added annually to the North Pacific. So very soon, contribution of tsunami will fade compared to our everyday activity. However, this is not absolutely right, because what was washed in the ocean by tsunami is not what is regularly deposited in the ocean during our routine ordinary life, and that's why, for example, tsunami debris, it has much more opportunity to transport invasive species, because especially ships, docks, other structures that were in water next to Hawaiian coastline for extended period of time. So they had time to be colonized by Japanese species, and then they are built of materials that can last for many, many years. And this debris provides perfect ride across the ocean.
One more question. The ocean conveyor belt that goes around the planet, that's going to carry this debris, or is the debris just going to stop in the Pacific Ocean?
I did not hear full question. Can you repeat?
There's a ocean conveyor belt is what they call it, the currents. Is that going to continue to carry debris around the world?
The question is, there is so-called ocean conveyor belt. Is it going to carry debris around the global ocean? Conveyor belt is a three-dimensional feature. Conveyor belt is driven by differences between cold poles and hot equator. So conveyor belt is essentially cold water sinking underneath warm water, and warm water entering Arctic and Southern Ocean. marine debris, as I said, it does not sink. For floating objects, equator is nearly a wall, like a wall. So, but there are always exceptions. There are some anomalies. There are also boundary currents that can provide some leak. But generally, marine debris does not travel across the equator.
Okay, well, thanks. Let's thank Nikolai, and if we
Thank
have
you.
any further questions, we'll take them.
She's calling me. Guess I'll slide away. I've got to feel her touch most every day. She's warm and she's wild, calls me her child. I warm to her touch. She's my mother ocean. How I love her. Often she rages. It's anticipated.